Okay, um, I'm going to show folks how to do an exploratory factor analysis. Um, so what we have here is a measure I created to assess four types of spirituality as a personality trait. Um, so the first set of items looks at a sense of closeness with God, and then I have parallel items for nature, humanity, and the transcendent. Um, so what you do is you go to data reduction factor, and I already selected the items and kind of pulled them over here, the ones that we want. Under descriptives, check these things. Under extraction, I usually use principal axis factoring in SPSS. And then ask for the scree plot. In terms of rotation, we want an oblique, which allows the factors to be correlated. Um, if if it turns out the different subscales are completely uncorrelated, that'll show up even in an oblique rotation. But I generally don't like forcing them to be oblique. Um, there might be situations where someone might argue for that if they're really wanting to kind of, I guess, maybe maximize the differences between the subscales, kind of the distinctions between them. Probably helps make the case that um, that your subscales are kind of doing different things. And then finally, I do pairwise, and I'll sort the loadings by size, and also suppress less than 0.20. Usually I use a guideline of something like I'm looking for factor loadings above 0.50 on the primary factor, and I'll usually rule out cross loadings of 0.25 or maybe 0.3. So we'll see what that looks like. So you hit paste, send your syntax over. So I had already run this once, so it'll stick it at the bottom here. What I had done before is I had about 400 people, so I split the file and saved it in a couple different ways, and then for this data set, I filtered off um, half the sample is what that's doing. So if we highlight this and hit play, it's going to run it for us. So we get descriptive statistics. You'll need that for your table. Correlation matrix. So one rule of thumb for deciding how many factors to extract is at the point where the eigenvalue is less than 1. The eigenvalue has to do with kind of how much variance is explained, and when that drops below 1, it means that the new factor is explaining less than one item, so kind of doesn't make sense to retain a factor that's doing less than a single item. So another rule of thumb is you kind of look at the scree plot and where you get this elbow, like all of these factors are kind of, this is based on eigenvalues, so all of these are explaining about the same amount, and then you get a jump here with, so the first 4 factors are doing quite a bit more than the rest of the factors. That's how you look at that. So these are unrotated, so it doesn't make a ton of sense to look at those. What we want to look at is this rotated solution. And Develis talks more about what the rotation means, but it just helps you interpret the loadings more clearly. So generally what we're looking to see is that these items were kind of loading on the different subscales based on the target of the sacred. So the transcendent, transcendent, transcendent. This all looks good. Nature, nature, nature. Um, God or personal deity, and then humanity. Um, so this is amazingly clean. I mean, we're not getting any cross loadings above 0.20. All the loadings are really high. Um, not even, nothing's even close to our threshold of 0.50. We may run into a little bit of problems with the CFA because sometimes when your items are so strongly correlated with each other like this, um, it actually indicates they're too strongly correlated. So we'll see what that looks like, but we may need to um, drop some items just because they're loading too strongly with each other. Another way we could get at a similar thing is we could probably run the same analysis in M+, and it gives you model fit indices, and probably what we'd see is if this was a problem, the RMSEA would be a little high because it has a penalty for redundancy. And then it gives you the factor correlations with each other. Notice we're not really getting super strong correlations across the different factors. I mean, 0.44 is about a little over 20% of the variance. So some of these are approaching a strong correlation. So if we had run into problems with the pattern matrix where we had cross loadings, what we would do is we would, in the next round, exclude items that didn't meet our criteria, and then we'd rerun things until all of our items met criteria. And the way you do that is, say we were going to drop items 2, 3, 4, 5, 6. So you could just delete those from here and here